You freeze time. A coffee cup falls off a desk, but it stops half an inch before hitting the floor. You step out of your chair to take a walk through a motionless world. Movie magic lied to you. If time actually froze right now, you wouldn't get to run around like Quicksilver or pull off a cool heist. Within one single nanosecond, you would be instantly blind, completely deaf, utterly paralyzed, and boiled alive from the inside out. We've all fantasized about pausing the universe to get extra sleep, cheat on a test, or save the day. But pop culture ignores one fundamental truth. Time and motion are the exact same currency in physics. When you freeze time, you don't just stop clocks. You freeze every single subatomic particle in the universe. And when matter stops moving, the laws of physics don't pause. They turn violently against you. By looking at 3 microscopic breakdowns, you'll discover why the ultimate superpower is actually a cosmic death sentence. According to Einstein's theory of special relativity and the fundamental principles of thermodynamics, velocity is defined as distance divided by time, delta x over delta t. Setting delta t to absolute zero creates a division by zero error in the physical laws governing light propagation, wave mechanics, and particle momentum. Open micro question. If you frozen time superhumans can walk around, why is the very first thing you experience absolute, impenetrable darkness? Human vision requires light, specifically stream of photons, elementary particles of light, hitting your eye's retinas at roughly 300,000 kilometers per second. Your brain processes these incoming collisions into visual images. When time freezes, light stops moving. Photons freeze in place like suspended glass beads. No light enters your pupil. To see even a single blur, you would have to physically scoop up stationary photons by walking your eyeballs directly into them, meaning you'd only see a hyper-distorted instant flash of whatever light hung directly in your line of sight, followed immediately by total darkness. So what? Vision isn't passive, it's a constant bombardment of moving energy. If light stops traveling, your environment vanishes. If you ever wanted to explore a frozen world, you'd be doing it entirely by feel. Except feeling things is even worse. Open micro question. Why would taking a single step forward feel like running head first into a solid block of steel? Air feels soft because gas molecules are constantly bouncing out of your way as you walk. But air has mass. When time pauses, every single molecule of nitrogen, oxygen, and carbon dioxide freezes dead in place. Moving through frozen air isn't like walking through thin mist. It's like trying to push through a solid block of concrete with zero give. You couldn't push air molecules out of the way because pushing requires transfer of momentum over time. Even worse, you couldn't breathe. Your lungs create a pressure differential to pull oxygen in. With frozen air molecules, no gas can enter your trachea. Even worse, you couldn't breathe. Your lungs create a pressure differential to pull oxygen in. With frozen air molecules, no gas can enter your trachea. You are trapped in a personalized, impenetrable mold of your own body shape. So what? Matter is only fluid because time allows particles to move around each other. Remove time, and gas instantly behaves with the structural rigidity of diamond. Open micro question. What happens to temperature when molecular kinetic energy hits absolute zero across the universe? Temperature is literally just a measurement of how fast molecules vibrate. Fast vibration equals heat. Slow vibration equals cold. When time freezes, molecular motion drops to zero.
That means every object around you instantly plunges to 0 Kelvin, negative 273.15 degrees Celsius, or negative 459.67 degrees Fahrenheit. Absolute zero. The heat in your body would instantly radiate outward into the infinitely cold, non-vibrating air vacuum around you. Without time to regulate atomic vibrations, thermal conduction strips your body heat in milliseconds, freezing your cellular structure instantly. So what? Time isn't an abstract clock on a wall. It is the fundamental engine of heat and energy transfer. Stopping time is functionally identical to triggering the instant heat death of the universe. But let's assume you somehow survive all of that. You have a special sci-fi suit that lets you breathe, see, move, and stay warm in frozen time. You walk around for 10 minutes, touch a few frozen objects, and then press the button to unfreeze time. You just destroyed the planet. When you walked through frozen time, your suit exerted force on stationary particles to push them aside. Because those particles moved across a distance in 0 time, delta t equals 0, their velocity relative to the rest of the universe was theoretically infinite. The second you unfreeze time, every single air molecule, dust particle, and photon you bumped into instantly accelerates to relativistic speeds. Pushing a single air molecule out of your path while time was frozen imparts infinite kinetic energy into that molecule. The moment time resumes, those displaced air particles unleash nuclear-scale fusion reactions, creating a hypervelocity shockwave that detonates the atmosphere around you with the force of thousands of atomic bombs. Unfreezing time doesn't resume normal life. It instantly vaporizes your entire continent. Here is the ultimate takeaway. Never view time as a background stage where reality happens. Time is an active physical variable bound directly to light, temperature, and atomic energy. You cannot alter time without breaking every law of physics that keeps your body alive. If stopping time entirely destroys the universe, what happens when gravity gets so extreme that it slows time down near an event horizon without breaking light waves? You need to explore how black holes stretch time into infinity.